Okay, so now volume. What is volume of object or a space available or of a container? Volume is basically the area of the base multiplied by the perpendicular height. The area of the base multiplied by the perpendicular height. So all you have to identify is that what makes the area of the base. Then you multiply the perpendicular height. That's all. This is the general formula. Take note of this. We are going to apply this. Good. So let's go. So it's a three-dimensional object or shape. Therefore, your answer must be in cubic centimeter, cubic meter, cubic millimeter, cubic kilometer, and all that. Three-dimensional. Why? The area is already length and breadth, which we have length. So that's two sides, two-dimensional. Then you multiply by the perpendicular height. Not just any height, but the perpendicular height. So area of the base, general formula for all the shapes or all the objects is area of the base multiplied by perpendicular. So now let's go. Let's look at this cuboid. Cuboid is length, breadth, and height. So area of the base is what? Length and breadth. Then you multiply the perpendicular height. It's not so simple. So length and breadth is the area, then times height. We are done. Let's look at that of cube. A cube is length times length. The height of the cube is also equal to its length. All the sides are equal. So area of the base is length times length, which is length squared. Then multiply by another length, which will give you what? Length cube. Simple. Good. Let's look at cylinder. Cylinder, we've already learned what makes the area of the base of a cylinder is what? It's a circle. So area of the base is circle, and the circle is pi r square times perpendicular height. Are you convinced here? Thank you. So area of the base. So what makes the base is very important. So what makes the base a circle? So pi r squared, which we have just learned, times perpendicular height. Now let's look at cone. Cone is just cut out of cylinder. It's just cut out of cylinder, just like this. You just take it out of a cylinder like this. Simple. And per accurate estimation, it is 1/3 of a cylinder. So you just introduce 1/3 in front of cylinder formula. Are you convinced here? It's so simple. It's just 1/3. When you cut it out with accuracy, it is 1/3 of a cylinder. So volume of a cylinder, then introduce 1/3 in front. Okay. Sphere. Already we have said area of the base is 4 circles. Area is what? 4 circles. So 4 circles, which is 4 pi r squared times perpendicular height. Good. Take note. These are the features of a sphere. The sphere is also 1/3 of a circle. Let's use football as a typical example. If you place a football on the ground, only 1/3 of it lies on the ground. Yes, so we use that as a basis. So we introduce 1/3. That's why it's 4/3. Because 1/3 times 4 means 4/3. Because 4 times 1 is 4. Then over 3. So that's it. So you introduce 1/3 when it comes to sphere. Then multiply by the perpendicular height. Now, the height of a cylinder is also equal to its radius. Take note. The height of a cylinder is equal to its radius. For that reason, instead of writing times I, we say times another r. So r squared times another r will give you r cubed. So the formula remains 4/3 times pi r cubed. That is the only formula here with r cubed. So take note, because the radius, the height that we have to multiply is the same as the radius of a circle or of the sphere or the football. Let's use that as a typical example. An introduction of the 1/3 is normal. Like I've told you, if you put a football on the ground, only about 1/3 of it will lie on the floor. The rest is out. So use that as a basis to also remember this formula. Hemisphere, you just introduce half. Hemisphere is half of a sphere. So half, 2 cancel 4 twice. So to remain 2/3 and that. And when the hemisphere is cut into 2 or the sphere is cut into 4, you end up get one circle right? So that'll be pi r cube. So one circle, pi r square times um times another r. That will give you pi r cube. Take note of that. All right. Let's look at square base pyramid. So as usual, the base is made up of length. So length times length. So that's a square. So length times the perpendicular height. So L square times height. Then we told it 1/3 because this is also 1/3 of, if you look at the shape, it tells you it's 1/3 of a cube. So you introduce 1/3 in front of it. So all those with this pyramid, uh, this kind of pyramidemic shape, if it's a good English, are you okay? Take it like that. So with that apex, you introduce 1/3 into it. So cone is one of them. When it comes to volume, introduce 1/3. Then you introduce 1/3 for the sphere, introduce 1/3 for pyramid, right? And the rectangular base, the rectangular base is length and breadth. So times perpendicular height. Then you also introduce 1/3. So this is also simple. And on that note, we are done with volume and surface area of solid figures, which are everyday objects or containers that we use. So application of these formulas is what we will see in the examiner's answer or in the examiner's questions being given to us. Just application and nothing else. So I'll do one or two questions. I'll solve one or two questions for you from past questions. That's what's the past question for you to see how the examiner framed the question and how you have to deal with that. So take note. Thanks so much for watching. This is volume and surface area of solid figures. That's mensuration 2. That's the end of it. If you have any question, let me know. Let me address it as I send the questions to you.